Alright, so today I have on the bench is a Pioneer SX-255R. This came into me from a buddy of mine and he wants me to take a look at it for him. I think he's been in there doing a little bit of work and trying to troubleshoot this prior to me, so I'm not exactly sure where he's left off troubleshooting, but so the first thing I want to do before I power this up is at least check out what's been going on so far, see what he's done, and see if I can come up with a solution for this. So I've already got the top pulled off, and I'm just doing my initial inspection here. And I think this was a plant stand. I think my buddy had said that as well, because it seems like there may have been some water damage. And I do see, if you look closely right here, that there's a little burn spot on this power circuit board from the transformer. And it looks like there's a little bit of carbon residue here between a couple of traces. So I'm going to have to clean that up and fix those solder connections. They don't look too healthy. But as you can see, all the corrosion is starting to take effect here. And that could have been part of the problem, or not. But definitely created an issue where it started to build up carbon, so it was kind of burning a bit. I think the problem, he said, was in the amplifier section, and I think he scabbed in that resistor to try something, and I'm not sure how much further he got than that. So it looks like a two-channel amplifier, so it doesn't look like it's going to be too complicated to troubleshoot. So yeah, that's where we'll start. I have the service manual for this. It's readily available on the internet, so if anybody's looking for it, just Google service manual for SX-255R and you should get the service manual. So yeah, I'm going to go through this circuit board and see if I can find other stuff. I mean, there's a little bit of corrosion here. Like I said, the transformer, so this may have seen some water damage that may have caused the issue, or I'm not sure if it's a shorted speaker or something that may have caused an issue with the amplifier. So I'm just going to make sure it doesn't, there's nothing evil shorted out before I power it up, and we'll see what it does. Alright, so I decided before I power it up I should probably fix that carbon issue on that power supply transformer circuit board. And what I have done here is basically scraped out all the carbon and gave it a nice alcohol wash, and I have routed two new wires in place of on top of the traces that were compromised, and this should take up the current handling of those traces and take it away from the trace that is now compromised because it's thinner, and these should not create any heat anymore across these two traces. So this should be pretty well repaired. I have put a conformal coating layer on top of the traces, so the corrosion should stop happening at this point. So along with the alcohol wash and the conformal coating and the new wires that are in place, that should restore the electrical connection and long-term stability of corrosion on this circuit board. So I think now that this is repaired, we can move on to the troubleshooting of the amplifier itself. I'm just trying to take care of the obvious stuff right now, so I'm not gonna get bit in the ass by something like, you know, this is gonna blow apart on me while I'm troubleshooting or cause another issue somewhere else. So that's the best thing to do, is try and take care of the obvious issues first, because sometimes the obvious issues are the issue. And I don't think this is the issue with the rest of the amplifier. I think there's other issues, but sometimes this could be an issue where the point where it would, you know, not turn on or do something silly. So try to take care of the obvious problems first before you move on to the more difficult, in-depth issues. And you know, the reason why I show you guys all these videos is I want you guys to, you know, if you're interested in repairing this stuff, because I mean you must be if you're watching these videos, you know, this is the type of stuff, you know, you gotta try and, if you're trying to learn this stuff, you want to try and get in there and do some of the stuff yourself. I get a lot of questions on my channel asking me how to repair this or can I repair this, and yeah, I can repair stuff for you, but you know, the reason why I do these videos is because I want you to try it, you know, and that's the whole point. You know, it's sad that all this stuff ends up in a landfill and you have to go out and buy, you know, spend another $300 or $400 for a receiver to replace it when, you know, it's something stupid usually most of the time. But, you know, I know a lot of people don't have the experience or the knowledge how to do stuff, but that's why I'm trying to teach you some of the basics to go in and look for some of the stupid stuff that goes wrong with these things. So, alright, so I'm going to get into a little bit more and try and troubleshoot what's going on with the amplifier. The circuit board itself looks okay. I don't see any real severe water damage on the circuit board, so we might be in luck in that respect. I can't really get to the bottom side of this circuit board without taking this whole receiver apart because of the design of this receiver, which is probably not meant to be serviced from the bottom. Usually they'll put an access panel here on the bottom, but I hate when they do not, because it just makes it so much more of a pain in the ass to try and get this repaired, because you actually have to pull all the screws out, disconnect everything, and it just makes it a nightmare. And not only that, but it doesn't make it easy for you to test the receiver when it's all unplugged and in pieces. So if you think if you're trying to troubleshoot a repair that you just did or a circuit, it can be a little bit troublesome trying to get a scope in somewhere when everything's disconnected and floating around. It just makes it a little bit more difficult and possibly, you know, more unsafe, and you can possibly short out circuit boards on the case or something, and yeah, I just don't like that. I hate that they stopped doing that on some of the lower end models, you know, putting access panels to the circuit board. The ones with the access panels, the circuit boards are nice. It's just a little panel that will unscrew from the bottom and you can get to the solder side of the circuit board, and yeah, it just makes it a whole lot easier. And that's why I think a lot of these end up in the trash, because they don't do that stuff anymore. They don't make it easy for you. And, you know, I mean, the decal's falling off this thing. So, I mean, I'm sure this wasn't their high-end model, just judging by the circuit board. This is a pretty chintzy circuit board. This is like the crap that Sony used to put in their receivers and stuff. It's a real thin, crappy, flexible circuit board. It's not very good quality. So, I mean, right off the bat, you know, this was meant to be a disposable receiver. So, but, you know, they can be repaired. It just takes a little bit more effort on your part. Alright, so I try troubleshooting the rest of the issues with this. Alright, so we're going to power this on and see what we got. Like I always say, we're working on electronics. You got to be careful with voltages when it's plugged in and unplugged, because there are some large capacitors that can store energy. So, you know, work on the stuff at your own risk. You know, be smart. Don't be brave and try to discharge capacitors with a screwdriver or something, and you know, you could potentially hurt yourself. Use the proper equipment and safety precautions when working on open equipment like this. So, well, let's fire it up, see what we got. I have the generator on, the kilohertz. I'm putting in about a 300 millivolt signal peak to peak. Let's kick that on. And I have the oscilloscope set for 2-channel, 5 volts per division. Let's see what we got. Alright, she kicked on. No protection. And look at that. We got signal. Yeah, I wasn't expecting that, so maybe that this circuit board did have an issue with that carbon building up between those two traces, causing the initial issue. I'm not sure. I'm going to have to hook up a set of speakers to this and verify that the output is stable. I am getting rail across here, roughly about 35 volts peak to peak. So I think she's doing her job. So I think the only thing left to do here is throw in a couple of speakers and see what she does. So if that was it, then that was a simple fix. No big deal. That's why I said always check the obvious stuff first, because sometimes the obvious stuff is the issue. Alright, so I'm going to put some speakers on this and see what we got. Alright, so I have the pair of speakers hooked up to this now and the oscilloscope, and it appears to be doing something a little bit more sinister. So I think that the problem is still exists. I think there's something going on with the right channel, and I'm going to show you what I see here. If you look on the right channel, you probably can hear that the left channel sounds really good, but the right channel is low and distorted. So this is, I'm going to just hit my balance control. That's the left. Sounds good. Let's go to the right. It almost appears that we're missing half the sine wave. So we're going to have to go dig in the right channel a little bit and see what we can find. And go through the schematic, and hopefully we can come up with something a little bit more substantial. Alright, so we're back here with the schematic. And this is going to be, you have an N part, a P part for your output transistors, and they all combine into this I think it's a 0.1 ohm or a 0.3 ohm resistor here. It's a center tapped resistor here that you have 0.1 or 0.3 ohm on one side and 0.1 or 0.3 ohm on the other side here. And the emitters, these are called the emitter resistors. These are those 3-pin white resistors that are on the board here that are probably about between 3 and 5 watts. And these take up a little bit of the discrepancy in the transistor, and they combine the signal and send it out to your speaker or relay or whatever is following in the circuit here. But that is your output here, is where you're going to want to test. So I'm going to put my oscilloscope at this point and see if the distortion is here. I'm going to assume it's here because we still hear it in the right channel. So we're just going to get the oscilloscope. I got it set to single channel right now. I'm going to get the lead here. So I'm just going to go to that center pin. First I'm going to turn this down and get it to a... just going to isolate the bad channel and see what we see on that center pin of the resistor. And I'm going to have to turn my scope to a little bit lower voltage here, or turn it up a bit. Alright, so we're still seeing it. We're still seeing it there. Alright, so we're definitely still seeing the issue at the output of the final stage. So what I'm going to do is I'm going to follow it back here to the pre-driver preamp section, and we're going to test it right here at R134. If it's still good, actually, you know what, I'm going to test it right here between R328 and 326, see what we get. And I think that is somewhere around here. Yeah, okay, so we're still seeing it, and you can see the top of the sine wave is missing. The bottom half is there. So this is kind of like a push-pull amplifier, and what happens is if you divide this half of the section here, this is going to be N section and your P section, and what happens is, picture this line as being 0. This is just kind of just an idea of what's going on. Everything down here is creating the negative sine wave, and everything up here is creating the positive sine wave. So if you got your bottom dips going like this, then you know your bottom part of your sine wave is most likely working, and then you have your positive signs that create the other half of the sine wave. So it goes up, goes down, goes up, goes down, goes up, goes down. So if you have one half of the circuit not working properly, you're going to have a flat line. And if the other half is working, you're going to have that sine wave, of basically what you saw on the oscilloscope there. So to try and decipher which side of the amplifier is the P side and which side is the N side, you should be able to find somewhere that these rail voltages come from. And you'll see there's a rail here and there's a rail here, and they all come down to these 2 points. And on this particular schematic, it shows that the plus 47.4 volt rail is the bottom half of the amplifier, and the negative side is the top half. So don't get confused when you're looking at a schematic that the top is the positive and the bottom is the negative, because that is not always the case. Try and find your rail or measure them and find out what side of the amplifier it is. So you got minus 47.4, positive 47.4, and we know that the bottom side of the amplifier is the positive side that we're having an issue with. So I started probing around. All these resistors here with the F on them are fusible resistors. Well, I think that's what I'm calling them. They're easy open resistors, and if they see any overload, they just open up. So I had checked all these prior to diagnosing the amplifier, but I think I may have missed one, or didn't see it on the multimeter correctly, because this resistor here is open, and so it must have saw an overload. So I'm going to say it's probably going to be an output transistor, or this pre-driver transistor, or something that is on this section of the amplifier. I think that we're going to be good here, because I checked those, and I've checked these, and the only thing I haven't checked is this. So I'm going to check that and see what I come up with on Q306. I have checked, let's see, what else have I checked here? I've checked a lot of the diodes in this circuit, make sure there was no shorts, because those are that's a very common issue for a diode to short out and cause some problems. So I'm going to show you what this is, that open resistor, and let's see if I can get in here. It just reads in the megohm range. I've already desoldered the output transistor in this channel, and that transistor is good. So I think I'm going to check, let's see, where is it? This transistor right here, and check that for any issues. And if we find a short on this, then we'll pull it out and make sure that it's shorted, and we'll go from there. Am I on the right one? Alright, so I'm on Q306, and I am measuring right now between the collector and emitter, and I see a direct short here. So that right here is telling me that this point and this point is shorted together. So yeah, this part needs to be changed. So yeah, so we'll change that part, that transistor, and we'll change this resistor out, and hopefully this channel will come back to life. Okay, so we got this hooked up to the DCA55 semiconductor component analyzer. You can use a regular multimeter, that will work fine in diode check mode. So I have the emitter base and collector hooked up to the red, green, and blue. So let's give this a test. Short circuit on blue and green. So that is the collector and emitter of the transistor. So I'm going to have to try and find a suitable part to replace this with. And this is a 2SA1145. So yeah, I'm going to have to see if I can cross that to something I might have here in stock. Alright, I think I finally got this figured out here. This thing has been leading me all around. There was a ton of problems that led me down a bunch of rabbit holes to dead ends because of the multitude of components that were failed. There were, right now I just have some parts scabbed in here. They're not the exact replacements. I have 2 resistors, 2 diodes failed, and let's see, 1 transistor failed. They kind of just piggybacked on the open resistors right now, the replacements. And I have a similar transistor in its place. It's not the exact part. So, but for testing purposes, this is completely fine. This gets you up and running to the point where you can order parts for it and have the right components fitted for the PC board. So let's go through the schematic here and find out what was blown. This R348 was no good. Let's see, this transistor was no good. The 2SA1145 Q306. D310 was no good. So I replaced that Zener diode. That was a 3.3 volt Zener. There was another resistor that was no good. I believe it was R35. Oh, sorry about that. I believe it was R352 was no good. And D338, which is a 10 volt Zener, that was no good. Once I replaced all those, I think we're ready for a test now, and we'll see what happens. Let's turn it up. We have CD. Wait for the relay to click on. Yay! We finally have a waveform that is normal. Let's check out the peak-to-peak voltages. Whoop, back out a little bit. They are roughly in the same amplitude. No distortion, very linear control. So yeah, I think that's it. I have to order parts for this to complete it, but to you guys, I believe this amplifier is repaired. I don't think you need to see the actual final parts fitted, but I think you just wanted to see that the troubleshooting process. This wasn't very long, and like I said, there was a few rabbit holes I had to go down to find the answer. At the beginning I thought there was an issue with the preamp circuit, but turned out that the feedback was incorrect from the amplifier section because due to all the shorts and opens that was happening. So yeah, that's it. I hope you guys enjoyed this video. I'm sorry if it's too long or kind of leading it down some rabbit holes, but that is the process of electronics. Is you will find yourself going down rabbit holes that you have many dead ends, and then you kind of have to go back and then go you know, in a different direction. And because at first I thought the final and pre-stage were okay, and I thought it was just a pre-amplifier issue or a low signal issue, but it turned out to be one half of the amplifier was falsely feeding back the circuit. So I hope you enjoyed the video. We'll see you in the next.